Okay, and in this video we now want to look at finding the area of a segment. So over the last two videos we've found how to calculate arc length, how to calculate area of a sector, and we want to finally conclude that with area of a segment. And the area of a segment is connected to the area of a sector. So remembering a segment is what you get when you draw a line from one side of the circle to another. You break the circle into two segments, okay? So we're looking at being able to find the area of a segment. So here in this diagram, I've got a segment shaded in pink here. Okay, so we're looking at this section here. All right, so we've got the chord and the arc length are bounding together that segment. So what we need to be able to think about here is that the segment is, we need to calculate first of all the total area of the sector, okay? And then we're going to need to take away the area of a triangle, okay? So we need area of a sector minus the area of a triangle. Okay, so area of a sector, we looked at in the previous video. It is theta out of 360 degrees times pi r squared, so it's that fraction of the total area of the circle. And then we're going to need to subtract a triangle, and obviously triangle is half times base times height, but we don't know those quantities. We've got this angle, so we want to use this formula that we've looked at in the trigonometry topic. So the formula for the area of a triangle, which is half AB sine C. Okay, so remember the angle has to be between the two side lengths, which is what we've got here. So in this case, it's going to be half times the radius, which are the two lengths, times sine of the angle in between them, which is sine of theta. Okay, and so we get, therefore, this, and so we get this particular formula here. So it looks a bit unwieldy, but it's actually just two formulas we already know. So it's really important in the geometry and measurement. You can get bogged down in there being lots and lots of formulas. It's really important that you keep your eye on what those formulas actually mean and what they're actually doing. Okay, so let's have a look at example 1. Find, correct to two decimal places, the area of the segment pictured. Okay, so the first thing we need to do is calculate the area of the total sector. Okay, so we need to calculate the area of the sector, which is going to be, so let's go. So we know the area of the segment is the area of the sector minus, and let's do this one in blue, minus the area of the triangle. Okay, so the area of our sector in this case is going to be 45 out of 360, which you might recognise as being 1/8, times the area of the total circle, so imagining that this sector is part of a much larger circle with a radius of 20 centimetres. So we need the area of that total circle, pi times radius squared, so pi times 20 squared. So that's going to be our area of our sector. And then it is going to be minus the area of the triangle, and the area of the triangle is going to be times, apologies for that, half times radius times radius, so that's 20 times 20, which is 20 squared, okay, times sine of that angle. Alright, and then we can put all of that in our CAS. If you want, you can calculate them as two separate things, but you can just type the whole thing in and get one number. I'll calculate them separately just so you can see what's going on. 45 on 360, which is 1/8, times pi times 20 squared is 50 pi. Oops, sorry. Minus, we've got half times 20 squared times sine, making sure that you're in degree mode, sine of 45. Okay, so as an exact value, that's 100 times root 2, but you can skip that step and go straight to everything being in decimals. I want that minus that, control enter. Okay, or if you want to work out those two things separately as decimals first, that's fine. But really, you know, the sooner you just get it in your calculator and work it out. So for example, this is 157.08, and the area of the triangle, which was 100 root 2, oops, is 141.42, and so therefore those two things, when we subtract them, is what I've already done up there. It's 15.66, correct, 2 decimal places. 15.66. And it's an area, so the units are centimetres squared. Okay, as I said, just put all your numbers in, punch the whole thing in your CAS and press Control Enter. It's fine. Alright, let's have a look at example 2. The segment pictured has area of 1800 centimetres squared. Find, correct to 1 decimal place, the size of the angle that subtends the arc. Okay, so it is the angle that's unknown and it is the area that is known. So again, let's focus on what we know. So the area of the segment is the area of the sector, which is theta over 360 times pi r squared, minus the area of the triangle, which is half times r times sine of theta. Okay, so in this particular problem, we know the area and the radius, okay, and it is the angle that we're trying to find. So we're going to substitute what we know into the formula, and we know the area is 1800, theta over 360 times pi times 50 squared, minus half times 50 squared times sine of theta. So we've just got that one unknown in the equation to solve for. Our CAS can do that for us. So menu 3.1, we're going to solve 1800 equals, control divide, x on 360 times pi times 50 squared, take away half times 50 squared times sine of x, comma x. Now I'm just going to press Control Enter here, see what happens. Yep, that's okay. Even though it's got a sine of x in it, where normally we need the domain restriction, because there's also this one out here, there's a restriction implicit in what's happening here, so we don't need to do anything more. And so we find that it's not x in terms of what we write on the paper. Theta is, and we want our angle to 1 decimal place, is approximately 127.8 degrees. Alright, and example 3, the final example. The segment pictured has area 15 centimetres squared. Find OA, the radius of the circle. Okay, so this time it is the radius that's unknown. We know about the angle and the area. Okay, so again, thinking about our formula, we know that the area of the segment is going to be the area of the sector, which is the angle over 360 times pi r squared, minus the area of a triangle, which is half times r squared times sine of the angle. This time we know the angle and the radius, okay, and so we don't know the radius, my apologies, the angle and the area, and so we can put that information in. So we know the area is 15, the angle is 80, sine of 80, and we can get our CAS to solve for r, which is what we're trying to find. Okay, so menu 3.1, we want to solve, our area is 15, and that is equal to 80 on 360 times pi times r squared, take away half times r squared times sine of 80, again making sure you're in degrees, solving for r. Now because of those r squareds, when I press Control Enter, I'm going to get two solutions, but again one's positive and one's negative, kind of a negative length, and so we know that r has to be, what do we want, 1 decimal place, 8.5 centimetres. Okay, so again, it's a slightly unwieldy formula, but it's just two things that we already know put together, and it connects three quantities. So if we know about the angle and the radius, we can find the area of the segment. If we know about the area and the radius, we can find the angle at the subtended by the segment or the arc length, and if we know the I've lost track of what we did. We can find, if we know the area and the angle, we can find the radius. Okay, so work today from exercise 19A and also an additional worksheet with some problems involving